Hello.
Hello. Thank you for taking an interest in the topic of vertical integration of sensor data, and also for tuning in to the second part of the Field Echo and Digital Twins. Katarina, in the first part, we talked extensively about SIG200 smart sensors and also looked at the topic of field bus integration. I had the impression that we could have gone into more detail about the issue of cloud connectivity, because one product came directly to mind, namely the Field Echo. Could we talk about that a little bit more? Could you maybe explain again what the Field Echo is all about?
I'd be happy to, Tobias. Field Echo is an open system and manufacturer-independent monitoring tool, which reaches across all IO-Link devices in the system. The web-based graphical interface enables easy integration into the machine and system HMI. In addition, there is also the REST API. This enables communication in IoT applications. And all this with only one line of PLC code. I think this is exactly the kind of simplification you're looking for.
With one line of PLC code, that sounds almost too good to be true. I know what a hassle it is to integrate IO-Link devices into a control, how much time it takes, and we can do it with one line of code? How exactly does that work?
With Field Echo, you only have to call up the supplied function block in your PLC program. You can then diagnose, parameterize, and monitor all IO-Link devices. You even get alarms if needed. Look here at the monitor. Here, for example, you can see the WL4 photoelectric sensor and its identification process and parameter values. You can also click on the dashboard to see the status of all connected IO-Link devices. This is important not only during planning, but also throughout the entire life cycle. And this is regardless of the PLC program, field bus, or IO-Link master used.
That really only leaves one question, doesn't it? How do our customers get this software? Or are there also limitations or restrictions that they should know about?
I'd be happy to explain, Tobias. The software is available for you, our customers, as a download on our homepage. It can be used as a trial version for up to 4 devices without any restrictions. However, if you need productive adaptation, then you need to buy a license. Please contact the SIG sales organization in your country to do so.
Let's now move on to a completely new topic, machine simulation. Automation brings us exactly to the point where we need higher and higher quality machines and higher performance. But we still have to watch the cost of the machine. You gave us feedback that you use virtual methods in the development process. Methods such as virtual commissioning, so a holistic virtual test of your system, your automation system, are simply part of the process. We now offer you sensor models that you can use in this virtual commissioning process. Katarina, would you like to explain this in a bit more detail? What is this sensor model all about?
I'd be happy to. You, our customers, have told us many times that crucial component models are lacking, or the level of detail is simply too low. Your designers or the programmers responsible for the controls need to invest their time and effort again and again to create the necessary models themselves. We at SIG therefore completely understand the feedback that you have decided not to use these models due to capacity constraints and have accepted the errors that can occur during commissioning, even if that means correcting these errors afterwards, which is time-consuming. And this is precisely the area where we at SIG would like to assist you in the future. To perform simulations in a realistic and cost-saving manner, it is essential to have detailed virtual models of the components available at the click of a button. SIG has developed the first simulation models of various sensors and employed them in a virtual system in collaboration with the company Industrielle Steuerungstechnik.
At the push of a button sounds really great, but you also mentioned the word realistic. So how close are we really to reality?
The simulation models from SIG take into account various sensor-relevant influencing factors such as angular position, level of gloss, color, or the transparency of the object being detected. In the end, it no longer makes a difference whether work is done on the field bus, so in the real system, or with a virtual component. That is what realistic means for SIG. You can see this for yourself in the exhibit. The simulation of the real exhibit is running here on this PC. The simulation is controlled via the PLC. This is also referred to as hardware-in-the-loop simulation. For example, I can manipulate the length of the block here on the screen. The real control then gives the virtual system the command to separate out the block because it no longer matches the predefined criteria.
That really sounds like added value to me. Added value that can also be put to good use in everyday life. I have one more question here. How can you get our sensor models now?
The sensor models can be exchanged via the ISG Twin Store, for example. In the future, however, we at SICK will also provide other platforms for these sensor models.
Sounds good. Yes, and that brings us to the end of our second part. I hope we were able to spark your interest in learning more about the Field Echo and our digital twins. Don't hesitate to contact us. Contact me, my colleague, or your personal contact person. Until then, stay healthy and see you soon.